Hello, grade 8 students. For today's lesson, we will be discussing linear inequalities in two variables. In today's lesson, you should be able to identify whether a given ordered pair is a solution of a given inequality or not. Let's have a short recall on our previous topic last year. So before, we asked you to create a slogan regarding healthy body. Now, majority of you answered this statement. So let's write an inequality statement out of this picture or statements. Number 1, drink at least 8 glasses of water a day can be represented as x is greater than or equal to 8. Next, sleep at least 8 to 10 hours a day can be written as x is greater than or equal to 8 but less than or equal to 10. Exercise at least 30 minutes a day can be written as x is greater than or equal to 30, meaning you can exercise beyond 30 minutes or at minimum of 30 minutes. Lastly, screen time for teens is at most 2 hours per day. It can be written as x is less than or equal to 2, meaning the maximum number of hours of screen time per teenager is 2 hours only per day. This is the reason why you only have 2 synchronous sessions every day. Next, when we are talking about linear inequalities, always remember that it is similar with linear equation in two variables. Why? Because linear inequalities in two variables also makes use of ordered pairs as its solution, and it also has infinitely many solutions. Again, the solutions are ordered pair and the solution is infinitely many. Now, let's identify whether the following ordered pair is a solution or not of a following inequality. First one is 0, 1, a solution of 3x plus 2y is greater than or equal to 5. To find out, always remember that in our ordered pair, it is composed of x and y coordinates. We can use that to substitute in our inequality. So given that we have 3x plus 2y is greater than or equal to 5, we can substitute the value of x and y to our inequality. So we have 3 times 0 plus 2 times 1 is greater than or equal to 5. And we know that 3 times 0 is 0, 2 times 1 is 2, greater than or equal to 5. And when we simplify this one, we have 0 plus 2, which is 2 is greater than or equal to 5. We know that 2 is less than 5. That is not greater than or equal to 5. Therefore, 0, 1 is not a solution of 3x plus 2y is greater than or equal to 5. Next, is negative 3, 2 a solution of 2x minus y less than negative 1? Again, we can represent our ordered pair by x and y coordinate. So, given that our inequality is 2x minus y less than negative 1, we can substitute these given values in our inequality. So, we have 2 times negative 3 minus 2 less than negative 1. To simplify, we have 2 times negative 3, that is negative 6 minus 2. Negative 6 minus 2, that is negative 8 less than negative 1. And we know that negative 8 is smaller than negative 1. Therefore, negative 3, 2 is a solution of inequality 2x minus 2 is less than negative 1. Now, let's have our last example. Is 1 and negative 2 a solution of x minus 3y is greater than or equal to 7? Again, in our ordered pair, we have x and y coordinate. So in our linear inequality, x minus 3y is greater than or equal to 7, we can substitute this given values. So we have 1 minus 3 times negative 2 is greater than or equal to 7. We can simplify. So 1 and negative 3 times negative 2, that is 6. Therefore, 7 is greater than or equal to 7. We know that 7 is not greater than 7, but it is 7 is equal to 7. Therefore, it satisfies our inequality. So we can say that 1 and negative 2 is a solution of x minus 3y is greater than or equal to 7. Now, it's very difficult to know if a ordered pair is a solution or not if the given inequality is not in standard form. So let's have a short recall when we say standard form. Let's go back in linear equation. We know that the standard form of the linear equation in two variable is ax plus by equals c. This is the same for the standard form of linear inequality in two variables. Okay? But the only difference is that the equal sign will be replaced by inequality symbol. So the standard form of linear inequality in two variables can be any of the following. Ax plus by is greater than c, or ax plus by is less than c, or ax plus by is greater than or equal to c, or ax plus by is less than or equal to c. So any of these can be a answer. Now let's write 2x is greater than 3y minus 4 in standard form. So first thing to do is to copy our linear inequality, and always remember addition property of equality and multiplication property of equality is not applicable in this given problem, but instead we will be using addition property of inequality and multiplication property of inequality. So for us to make this one into standard form, we will be subtracting 3y on both sides. So we will have 2x minus 3y is greater than negative 4. And this will be our final answer. We just transfer positive 3y on the other side. And when we transfer it, it became negative. Now, let's have this given example. Y is greater than or equal to 2x plus 3. Let's write it in standard form. So the first thing that we do is to copy our linear inequality. And to make this one into standard form, we will transfer 2x on the other side using the addition property of inequality. So we will have negative 2x plus y is greater than or equal to 3. And we know that when we are talking about standard form, negative leading coefficient on the x variable is not allowed. Therefore, we need to convert it into positive. So we need to multiply both sides by negative 1. So when we multiply it by negative 1, the answer would be 2x minus y is less than or equal to negative 3. What just happened is that whenever we multiply or divide any number in a linear inequality, the symbol will be switched. In this given example, the greater than or equal to symbol been replaced by less than or equal to symbol. Okay, I'll repeat. Every time that we multiply or divide any number in a given linear inequality, we will be switching the inequality symbol. Now, let's have our last example. Write y is less than or equal to x over 2 plus 3 in standard form. So let's copy our original inequality, and then same with the others, we will transfer x over 2 on the other side. So we will have negative x over 2 plus y is less than or equal to 3. And then because we have a negative leading coefficient and fraction as well, so we will be multiplying both sides by negative 2. Again, class, when we are multiplying or when we are dividing in linear inequality, the symbol will be switched. So when we multiply negative 2 on our linear inequality, it will be x minus 2y is greater than or equal to negative 6. Because we multiply the equation, the inequality by negative 2, our inequality symbol switch to greater than or equal. Now, it's your turn. Let's have a short exercises. So just pause the video for a while and then we will reveal the answer afterwards. Tell whether the given ordered pair is a solution to the inequality or not. For number 1, is ordered pair 2, -1 a solution for 4x minus y is greater than or equal to -1? Number 2, is -2, 0 a solution for 2x plus 3y less than -3? And lastly, is 3, 1 a solution of x plus 5y less than or equal to 7? Alright, so for number 1, 2, -1 is a solution. For number 2, -2, 0 is a solution. And for number 3, 3 and +1 is not a solution. If you got it correct, congratulations. Now let's have a short assessment regarding transforming inequality into standard form. For number 1, convert the following into standard form. Y is less than 3x plus 1. Number 2, y is greater than or equal to x over 3 minus 4. And lastly, number 3, y is less than 2x plus 3. Pause the video for a while and we will reveal the answer afterwards. Alright, so for number 1, the standard form is 3x minus y is greater than 1. For number 2, x minus 3y is less than or equal to 12. And for number 3, 2x minus y is greater than 3. That's all for today. Thank you very much. And do not forget to access your paper accounts for a short assessment. Don't hesitate to ask Sir Alex and Miss Ria if you have further questions. God bless.